Good morning, students. Welcome to another video lecture. Today, again, we are going to discuss about a numerical regarding a MUX. So, today, this question is implement the Boolean function using 2 cross 1 MUX and external logic gates. So, last class we discussed we need to implement a Boolean function using a specified multiplexer when there is nothing mentioned about appropriate multiplexer, or if they have given a specified multiplexer, how we can implement that Boolean function using that specified multiplexer. So, last class we discussed about a 4 cross 1 MUX. Now, this class we will going to discuss about the implementation of Boolean function using 2 cross 1 MUX. So as you can see that in this question we have a Boolean function which is having 4 variables a, b, c, d, and the SOPs are given 1, 3, 4, 11, 12, 13, 14, 15. Sometimes what happen, instead of giving these SOPs, they have given the Boolean function. Boolean function. First we need to convert into SOP, then we need to solve these numericals. So first, if I want to implement this function using 2 cross 1 MUX, so first I need to write down the truth table for the 2 cross 1 MUX. This is the truth table for the 2 cross 1 MUX. So in 2 cross 1 MUX, we have only one selection line, that is S0. You can see only one selection line, that is S0. And when this selection line S0 equal to 0, I am getting output Y equal to I0. And when the selection line is 1, I am getting Y equal to I1. Okay, so when I am writing this A, B, C, D as a 4 variable, and we have one output I have taken as a Y, or you can take as F also. So as it is 4 variables, we will get total 16 possible combinations of input. So as 16 possible combinations of input, we will get again 16 mean terms. Okay, so we'll write down here like A, B, C, D. So out of this A, B, C, D, and we will take only A as the selection line. Okay, so there are 4 variables. We have taken A as the selection line, and this B, C, D will take as the input for this multiplexer, and Y or F is the output. So as I told here, it is a 2 cross 1 multiplexer. So one selection line. So the possible combinations are either 0 or 1. So once I wrote the 16 pair of combination, then we'll write down the output. So the output will write from this SOP or the question given here. So the SOP basically 1, 3, 4, 11, 12, 13, 14, 15. So at these SOPs or at these mean terms, the output is going to be 1. So I mentioned all these outputs here. So wherever the SOP is given, there only I wrote the term 1, and in all other cases I will put the 0. So 1, 3, 4, 11, 12, 13, 14, 15, there only I got the output 1, and all other cases I will keep the output 0. Okay, so so in 2 cross 1 multiplexer, as I told before, so we have 2 possible combinations, either 0 or 1 of the selection line, and here I have taken A is the selection line. So we will need to make a group of 8. So we will make a group of 8 if I am taking A as the selection line. So you can see by putting this thing, I can see by taking 8 as a 8 combination or 8 in a group, I can say that S0 equal to 0. S0 equal to 0. And if I'll make the group of all the ones, 8 number of ones, so here it behaves as the selection line when S0 equal to 1. Okay, so once I keep like this, then I'll make the group of 8. So I'll do one thing here. So rest of things like B, C, D, Y, I'll make this as a table where the input variables are B, C, D, and the output is F. So now the relationship between output and input I can identify, or the relationship between output and input we can get by solving the K map. So let us solve the K map where the input variables are B, C, D. So it is 3 variable K map. So I'll get total 8 boxes. So first I made the K map, then wherever I am getting 1, that I kept it. So after putting all the ones, then I'll go for proper pairing. Okay, so here you can see here I got 1, I can got 1 across 1, 3, 4. So by keeping all the one and proper pairing, I got y equal to b bar d plus bc bar d bar. So which is nothing but the input, I0. Okay, so when I am selecting S0 equal to 0, I am getting the output equal to I0, which is nothing but b bar d plus b c bar d. Similarly, I will go to the another group of 8. So when I will take S0 equal to 1, then I got this group of 8. The same thing, I will take b, c, d as the variable and y is the output. So then by solving the K map, here you can see that I put all the ones across 11, 12, 13, 14, 15, or for this box I'll solve this BCD and I got here y equal to b plus cd. Okay, so when S0 equal to 1, I got y equal to y1. So two relations I got, one is for I0, another is for I1. Okay, so now as a question written here, by using 2x1 MUX and external gates. So you need to remember, we need to use also external gates. So let us go to the 2x1 multiplexer. So in 2x1 multiplexer, we have two inputs, I0 and I1 and one selection lines. So I already selected S0 equal to A, or I have taken out of A, B, C, D. A is the selection line and B, C, D as the input variable and Y or F as the output. Now I got I0 equal to b bar d plus b c bar d bar. So if you see it clearly, this is one AND gate, this is also another AND gate, and both will be connected using a OR gate. Okay, and we have using three variables b, c, d. So I have taken here b, c, d. So here I got b bar. So you can see I putting NOT gate. So I got b bar d here. So here I got b, c bar, d bar. Then both will be combined using a OR gate. So finally here I got b bar d plus b, c bar, d bar. So which is nothing but the I0 as I told. Similarly, for I1 I got here C, D. So I have put a AND gate. Then I have taken a B as a input. This is the B. So finally here I got B plus CD. Okay, which is nothing but I1. Okay, so you can see the question, whatever the question given here, then implement the function using 2x1 MUX and external gates. So here I am able to use the external gates like AND gate, OR gate, and a 2x1 MUX. Out of A, B, C, D, A is selected as a selection line and B, C, D as the input and Y is the output. I hope you understand this question. If you have any doubt, you can ask me in the comment section. Thank you for listening.